Welcome everyone. Hope you're having a good day. GM, please voice out in chat. Say hi. Don't be a stranger. I'm Yasin, and I'm happy to kick off the second event of the week of our Chain Abstraction Educate series, where we're going to be having Ankit from Frontier Research, who's going to be covering the topic of the Cake framework. He's head of research at Frontier Research, and we will be having an amazing workshop. Hope you're all excited. Let me just quickly add him on stage.
Hello, everyone. My name is Ankit. I do research at this thing called Frontier. Frontier was set up by Stefan, who was an ex-CEO at Flashbots. And almost 6 months ago, we published this thing called Cake Framework, basically trying to look at different ways people pass messages and value across blockchains, both L1s and L2s, and just trying to map out what are the different trade-offs different teams are trying to make, what are the tools or what are the Lego blocks that different teams have at their disposal to make one type of a product for their end users. And this is what Cake Framework is all about. I will try to speak for around 40 minutes, and then we might have around 15 minutes for questions after that. So what is Cake Framework? And the presentation is split into these 5 sections. Basically, what is Cake Framework? We'll just look at the evolution of the blockchain space over time and why we think that this is the correct time for doing something like chain abstraction. Then we'll look at what is chain abstraction itself and why is it needed. Then we'll look at what are the different parts of the cake and what are the design trade-offs that each and every part of the cake is trying to answer. And then based on these different trade-offs, there will be like 4 or 5 trade-offs that we'll talk about. Basically, are you trying to pass information or value? Are you trying to find the best price? Are you trying to find the best no loss of information? Or are you trying to optimize for reliability? Those are some of the trade-offs that people look for. And then finally, based on these Lego blocks that users have or application developers have, what are the 6 different types of applications that you can build for chain abstraction purposes? And then finally, we'll sort of conclude. So that's the TLDR of it. If you look, so why we basically wrote this blog post or this analysis at this point in time. Basically, if you looked at dApps in 2020, if some of you were there, then it was all about yield farming. People were able to basically spin up new applications like Yam Finance, and people were instantaneously able to deposit tens of millions of dollars into something like this, and it just got instantaneous, a lot of usage, but a lot of users had to pay tens of dollars or sometimes even hundreds of dollars to even make a single transaction when the blockchain was spammed. So at that point, the Ethereum's world computer use case was really shined, and you were able to see what type of applications you can build when you have a world computer. But there was no scalability. Users had to pay a lot of money, and so it was keeping out a lot of different types of users. In 2023, you have scalability. People sort of realized that now, because you will be keeping out a lot of users, you need a lot of parallelized blockchains, what we call rollups in Ethereum land. It got us a lot of scalability, but it got us a very bad UX. And so now over here, you can see that you have, if you open up your smart contract wallet, you have 3 different types of Ethereum, 2 different types of USDC, and it's a very buggy experience where if you want to do anything on some target chain, then you need to use something like this and then wait for a few minutes, maybe sometimes 17, 20 minutes, pay tens of dollars, and then be able to do what you want to do. And so we got cheap block space, but at the cost of UX. This also, so this is how the L2 landscape looks like. This is how L1 landscape looks like. Because there's so much volume or so much order flow being pushed through, a lot of specialized entities sort of emerged and increase the scalability. But now to actually do something, there are 10 different parties that you need to go through to actually get your transaction included. And all this is what we call as the solver layer. hopefully in 2024 we can have both scalability and usability and good UX, and that is what Cake framework and chain abstraction is all about. And what we have tried to do is basically segregate how a transaction flows through the blockchain or the blockchain infrastructure into 4 different layers. The layer 1 is application layer, which is basically things like Uniswap, things like Aave, where users are directly interacting with a website or a set of smart contracts. The second is the permission layer, where these are things like wallets or Telegram bots, or basically some sort of permissioning systems where the user can permission state access or some type of transaction to an application. Then the solver layer is this new type of entity that has sort of emerged when Ethereum L1 sort of gained a lot of activity. People call them solvers, searchers, paymasters, market makers. These are all different terms that we use to signify a type of entity that, if you look on chain, just looks like an address, but it is trying to basically give some service to the retail user, where the retail user basically cares about good UX, but the solver is giving them service about actually inclusion or better price and stuff like that. And then finally you have settlement layer, where things actually end up settling. And so things like oracles, L1s, L2s, bridges are what we are concerned with settlement layer, where they put the stamp of finality into what you're trying to do. So these are like 4 different layers of the cake. We have this argument also that Cake has sort of emerged from the MEV because the solver layer or the origin of the solver layer was from searchers. And we sort of made this Cake working group where there are a bunch of industry partners, and what we are trying to do is trying to come up with some set of standards for making chain abstraction or a good UX and scalability a reality. So that's where we stand with respect to the Cake framework and the Cake working group. But let's look at why chain abstraction. So what do we mean by chain abstraction, and why is it important, and why is it inevitable for users to achieve chain abstraction, is what we will look at in these slides or in this section. So let's forget about blockchains for a minute. Let's go 20, 30 years back, and suppose if you wanted to send, and if there are no standards, there's no HTTP, there's no SMTP, there's no IP address, all these kind of different type of standards that have sort of emerged for the Web2 ecosystem. And if you wanted to just send an email with a PDF attached to it, if you're getting married and if you want to invite someone, what would you have had to do if none of these frameworks or none of these standards existed? What you would have done is you would have gone to some sort of an email aggregator. You would have entered the from and to address and posted the PDF, and then you would have received 3 different versions of how to send your PDF. There's version 1, which is very quick, but it is very costly. There's version 2, which is sort of in the between, and then the version 3 is very cheap, but it takes a lot of time. And at the end of the day, you won't even receive your original PDF. You would receive something which is garbled a bit. You'll have a warped version of the PDF. The date is missing. But this is what would have happened in the Web2 space if all these standards of abstracting away stuff might not have existed. And in contrast, what we have is you have these beautiful email applications where you don't need to think about if you are sending an email from Gmail to iCloud, or the size of the PDF that you are sending, or what are the costs associated to it. You just drag, drop, and eventually send the email that you want to send. It's a very smooth experience for the user. But if you just compare to where we are in the Ethereum roll-up landscape right now, things are looking very fragmented, very buggy, and the UX is very bad. So this example is an example of, if you just open a wallet, you see 3 different types of Ethereum. You see some USDC, some Hop or some Matic on some other chain, and right now, what every user is trying to do is holding in their head how much value they have distributed across all these different chains. And if they want to do something, they have to collect all these assets and transfer them. Even when you're trying to connect to a separate application, you have to basically click on this switch network button each and every time, where instead of the application just figuring out what network you are connected to or what network you should be connected to, it's just asking each and every time the network switching capability, and it's just a bad UX. It's in Web2 ecosystems, you talk about 200 millisecond waiting times, where if a user is waiting for more than 200 milliseconds for anything, then you see a significant drop off. But in Web3 ecosystems, users are willing to pay tens of dollars and willing to wait for tens of minutes to do any single interaction on any target chain. And it just shows you the power of how powerful financial incentives are, that users are still willing to wait so much time and spending so much money to do something on some chain that is very new. But from a UX perspective, this is a very bad scenario that we are in. And then even if you have to send $1,000, this is a screenshot from a popular a bridge aggregator, you would only get $999, and you'll get $999, and then you also have to spend around $18 if you use CCTP, which is the cheapest. But there are other versions which are faster, but you need to spend a lot more. So this is where we are today. This is not equivalent to the simple drag and drop experience that Web2 has available for the users. We are most probably, this is also because we are very early in the development cycle, but this is just where we are today, and we need to basically change that. And so chain abstraction is basically the idea that the knowledge of the network is abstracted away from the user. This is very similar to Web2. So if you're using a DApp, then or if you're using an application like Skype or Zoom, you don't know or you don't care about if the application is hosted on AWS or GCP or some other cloud provider. You just log in, which is equivalent to connecting your DApp to the wallet. You click a button, and then the thing that you are expecting just happens. And because users have to basically understand where their assets are distributed, understand how to use a bridge provider, how to use a bridge aggregator, spend tens of dollars, spend tens of minutes to actually do what they want, this creates a very frictiony user experience. And similar to how in the Web2 ecosystem, most of the retail users don't care about the inner intricacies of the network layer, a lot of retail users will not care about where their assets are until unless they are secure. And so this is a very correct time to talk about chain abstraction, because block space is abundant. You can literally one-click deploy a new blockchain. You can go to Conduit, you can go to alt layer, and you can just one-click deploy a new L2. And so block space is abundant. It's the UX of basically migrating state from one blockchain to another and giving the user this instantaneous cross-chain experience is what is the bottleneck now. And removing all that knowledge requirement from the user, abstracting all that waiting and cost away from the user, is how you, in our opinion, will bring the next 1 billion users in the blockchain space. So that is chain abstraction. Basically, what we looked at in the last section was what is the difference between where we are in the Web3 space and what Web2 has to deliver. And then now let's look at some of the design trade-offs that are available when you look at different layers of the cake. So suppose if you are trying to design a cross-chain application, what are the things that you will have to care about? And so the first thing that you will have to care about is, are you transferring messages or are you transferring value? So if you're just transferring message, then these are like all types of message. They can be from transferring $100 from one chain to another, or they can also be things like, hey, I want to vote yes on some governance proposal. So message transfer is like a superset of value transfer, and value transfer is when you have to transfer value, this is what blockchains are made for. You have to make sure that the value that you have transferred is scarce and happens in an atomic fashion, so there's no double spend, and that is what blockchains basically solved. So value transfer is a subset of message transfer, but that is most of why blockchains are used right now. A message transfer can be lossless. So if you're trying to vote yes in a governance proposal, you don't want your yes vote to be converted into a maybe. But value transfer can be lossy. So if you're trying to transfer $100, you are willing to maybe only receive $99 and give $1 to a sophisticated entity who does something for you, who does some optimization for you. And so because one can be lossless and one has to be lossless and one can be lossy, for message transfer, you need to use the most secure pathways to transfer messages. Whereas to transfer value, you can leverage sophisticated third parties like solvers, the solver layer that we looked at, to actually maybe give you a better price, or maybe give you a faster execution or a speedier inclusion. And then message transfer encapsulates all types of transactions that happen, but 95 to 99% of transactions, especially measured by gas fees, are for value transfers. And then finally, some types of message transfers are governance, vote, or approvals, and value transfer is transfer, swap, gas. And so you need to be very specific about what type of application that you're building and what type of message you are trying to transfer. If you're trying to build just a swap application, then you can leverage these sophisticated third parties to do some of the job for you. But if you want to do a lossless message transfer, then you might be better off using bridges like L1, L2 bridges, or more secure bridges for passing messages. The second trade-off that exists is between UX versus agency, and that exists basically on the permission layer. And so if you think about, there are like the UX is a spectrum, and how involved a user has to be is also on a spectrum. So on one end, you have really hardware wallets and users who basically read each and every who basically match the signature hash to the thing that is proposed to them on the UI, and they only sign when things actually match. So this is a user who really cares about security. And on the other end of the spectrum, you have users who use Telegram bots. So they don't even care if their private keys are held in some other entity. They just want the experience of a good UX, of being able to buy the thing that they want to buy instantaneously. And so this is like user experience as spectrum, and you also need to really figure out what type of user you are building for. So there are different types of wallets or different types of wallet abstractions that have been built till now. You have like EOA wallets, where users have to basically sign each and everything and each and every type of message. So even for a cross-chain setting, users will have to basically sign messages for all different types of chains. You have account abstraction, where users can do batching, users can do basically more secure, and can also leverage paymasters. And so instead of holding assets in the EOA wallets and signing each and everything, they can give off some of those responsibilities to sophisticated third parties. And then you have policy-based wallets, where if you connect to perp exchange, where as soon as you log in, you have basically said that, okay, this perp exchange can trade N number of dollars for me, and I don't need to sign each and everything. I just click a button, and then that click a button is equivalent to me giving permission to generate some type of signature. So at the permission layer, you're trying to optimize, or there's a trade-off between UX versus agency. Then at the solver layer, the core trade-off that you are trying to figure out is, suppose there are multiple chains. So suppose a user wants to do some transaction from 3 different chains, pull funds from 3 different chains, and then execute something on the 4th chain. You need some sort of a mechanism to find the optimal route, to be able to tell the user, okay, this is, if these are the parameters for pulling funds from these 3 different chains, you pay this much gas fees, and you are able to pay the minimum for executing on that target chain. Or maybe there are other types of users who don't care about minimizing gas fees, but actually care about just landing the transaction on chain, and just want really fast access. then there are other types of optimization as well. So the core trade-off is finding the optimal route versus giving this execution guarantee to the user. There are some aspects that you can play with. You can, if you give all the information to the solver layer, there is this race that happens between different types of solvers, and they can also front run the information that, okay, there is a $1 million trade that is going to land. I might just front run this trade and make some money. And so the amount of information you share, or even the number of people that you share that information, can leak some value. And so when you're designing that system, you need to be very careful of that. And then you also need to basically figure out what type of users or what type of solvers you are giving that information. If you give it to all the solvers with some gated access, then you might be able to capture some order flow value, but at the end of the day, users are leaking value. And so if you share that information with a lot of solvers, you will get a better route because there is competition. But on the flip side, you might be leaking some value because you're leaking information. And so that is the sort of trade-off that you're trying to minimize when you are trying to make something on the solver layer. And then the third type of trade-off which exists is on the settlement layer. That is between low fees and execution speed. So there are some type of systems where you need to basically wait for a long amount of time to actually get a very secure settlement. So if you think about optimistic rollups have 7-day conflict windows where anyone can basically say that, okay, this type of transaction inclusion and the message hash that was posted on L1 is incorrect. And so the finality on optimistic rollups only happen after around 7 days. If you think about ZK rollups, then their finality happens whenever the proof is posted on the L1. And so if you want very strong settlement guarantees, then you might have to wait for some time. This will be cheap, but you will have to wait for some time. Whereas if you are willing to pay more fees and you are willing to leverage some sort of out of protocol actors like oracles or like shared sequences or some type of liquidity bridges, then you might end up paying a lot more fees, but you get this speedy execution where you bypass the core type of settlement itself. And so this is the main trade-off that you are trying to solve when you are trying to design some site, or you're trying to pick and choose some type of a system on the settlement layer. So in the last section, we basically saw these 4 type of layers of the cake, and each layer introduces their own type of trade-off. The first layer introduces the type of trade-off is like you need to make a decision. Do you need to transfer value or you need to transfer messages? There's a lot more type of value transfer type use cases today, and it might be better if you just optimize for transferring value. Then for different layers of the cake, we saw different trade-offs that exist, and there are trade-offs like UX versus agency trade-offs in the permission layer, finding optimal routing trade-off in the solver layer, and then finally the speed trade-off in the settlement layer. And so if you combine these 4 different type of trade-offs, you get what we call the cross-chain trilemma. And so you can only optimize 2 of the 3 things that we have laid out over here. So either you can optimize for execution guarantee, which is the user will have very high guarantee that their execution will actually land on chain. So in case of a swap, even if the price moves against the user, it will eventually land on chain. The second is low fees, which is if the user wants to have low fees, then they'll have to somehow either have to wait for a long time or bring in solvers. And then finally speed. So those are the 3 things, only two out of which the user can or the application developer can pick and choose. And depending on which two you want, you have these three different paths. And so we'll dig deeper into what each of these mean. And so if you want to optimize for execution guarantee and low fees, you would go with the in protocol path. If you want to optimize for execution speed and execution guarantee, you would go for some sort of an execution competition. And if you want good speed and good fees, then you will have a solver competition. And this arrow basically shows your propensity to increase the amount of solvers. So let's look at what in protocol paths mean. So even for in protocol paths where you are optimizing for execution guarantee and low fees and don't care about speed that much, there are two types of options available. One for value transfer, one for message transfer. So for value transfer, we call these things token unoriented bridges. So you can use it for really cheap cross-chain transfers. So examples of these are CCTP or XERC20. XERC20 is like a new token standard that has been proposed, where the source of origin of a particular token is the token team itself. And what XERC20 or CCTP does is the token teams basically anoint canonical token address on each and every chain that they want to support that token on, and select a bridge that can burn and mint the token on the target chain. So what you have is there is no slippage. If you just send your tokens to that bridge, so if you send USDC to the CCTP bridge contract, there will be no slippage, but you'll have to wait a lot. And you'll have to wait a lot because the CCTP bridge really wants to make sure that all the transactions are finalized and there's no way, shape, or form that the CCTP bridge eventually ends up double spending. And so everyone is trying to wait for finality. And so this is how you get execution guarantee, that even if you say, because you're just transferring funds, if your funds land on chain, then eventually they will land on the other side and you basically pay no slippage. So these are called burn and mint bridges as well. And then the message transfer example of this are called ecosystem aligned bridges, where you have these different ecosystems which have their own secured or anointed pathways to pass messages between each other. And so Polygon has Aglair, Cosmos has IBC, Optimism has Superchain. And so they use the canonical paths of how they deploy new L2s or how they deploy the whole ecosystem in basically doing this cross-chain message call. And even there, they're relying on the most secure pathway, on the most secure settlement mechanism to basically pass messages across. And which is why you can expect high execution guarantee. You can expect this payment of very low fees, but you need to wait a lot because they're relying on the most secure pathways. The second is what we call as solver competition. So here you are trying to optimize for speed and price. So you want to, you don't care about execution guarantee. You don't care if maybe 1 of 1,000 or 1 of 100 transactions don't land on chain. What you really care about is giving the users this experience of very fast and cheap experience. And so there are a set of applications called cross-chain aggregators. So Bungee, Jumper, UniswapX, which basically for value transfer do a competition between different types of solvers and just make sure that there is a healthy competition between solvers. All the solvers get all type of information. There might be some gated access. So for 1 inch you need, or CowSwap, you need to stake some amount of tokens. For UniswapX also there's some gated access. But you can basically create an aggregator of all these different type of swap providers and give the user, do some competition and pick the best one, and or let the user pick the best one that they want, and give the user this experience. And on the flip side, when you're trying to pass messages, then it looks very much like an aggregator of an aggregator. So over here you have just an aggregator of swaps. On the wallet control messaging, the wallet is in the best position to basically aggregate both different type of bridges or arbitrary message passing bridges, but also these solvers. And some examples are Alfred, Avocado, Near Account Aggregator, where the wallet basically just picks the best one and then uses that for transferring messages. And then the final one is what we call as execution competition. And so you don't care about low fees. So you don't care about paying the lowest amount of fees, but you really care about speed and getting the transaction executed with as high efficiency as possible. So some examples of this are Across and Arbiter. So even Across, so where in the earlier example, there was a solver price competition where solvers were trying to compete on price. Here solvers are trying to compete on speed. And so Across basically brings in all these different types of solvers and tells them that there's a user request to transfer maybe $1,000 from chain A to chain B. Whoever is able to satisfy the user request the fastest gets whatever the fees we are quoting. And so solvers are trying to compete to be the fastest for the user, and that is how you get this solver speed competition. Similarly, for message transfer, there are some examples in Web 2. There are not many examples in Web 3 where what these order flow originators do is they every maybe a week or a day, they select one particular solver and give them all the order flow. So instead of leaking all that order flow to one particular to a bunch of solvers, you give all the order flow to one particular entity and tell to them that I just want high execution, and if you're not willing to execute, you will be kicked out of this competition. And that is how you are able to transfer all different types of messages. So what does this type of analysis lead us to? This leads us to these 6 pieces or slices of cake. So if you want to do value transfer, you have these 3 different mechanisms where if you want to optimize for if you don't care about speed, then you can do like a USDC CCTP route. If you really care about price and want to optimize that, then you go to Jumper and Bungee. Or if you really care about speed, then you can go to Across. So just for transferring value across different types of chains. And for message transfers, if you want to transfer some type of message and you don't care about speed, you really want that message to be transferred as losslessly or as securely as possible, then you use the ecosystem aligned bridges. If you want to have some sort of a solver competition, then you can do that from the wallet layer. Or if you care about just execution quality, then you can also leverage these batch auction type mechanisms. So these are like the 6 different designs that sort of emerge, and each are trying to satisfy a particular type of use case depending on where you lie on the trade-off life cycle, on the trade-off space. And these are what we call the 6 pieces or slices of cake. So I think this is where I would like to end up the presentation. And just to conclude, chain abstraction, in our opinion, at this point in time when the block space is abundant, is sort of inevitable and very much needed, because the block space is abundant and the UX of moving state from one chain to another is complicated, and users should not know what the network they're interacting with. Or a lot of users, or new type of users, that next set of users that will come in, they won't care about what network they're interacting with. They'll just care about connecting or logging in via their wallet and actually doing the thing that they want. We also introduced the Cake framework, which talks about these different elements or different layers of the cake and try to explore the trade-off space. What are the trilemmas and what are the different type of trade-offs that you're trying to optimize for? And as I showed you, we have this working group where we are trying to develop some set of standards, and we hope it will be like the icing on the cake. That's all on the presentation side. So Zaryab says there are two different narratives currently. Some see chain abstraction as a broad concept encompassing all on-chain complexities, basically saying that chain abstraction is simplifying everything on chain. And then secondly, others see it more narrowly in the context of multi-chain complexity. This is how I see it. Which one is correct? So I think I would narrow it down to multi-chain complexity. It is not trying to simplify everything on chain. It is just trying to say that, okay, like now we have all these different roll-ups, we have a lot of these parallel blockchains, parallel databases. How do we improve the UX for the user so that for the user it is still a 200 millisecond experience even in this multiple blockchain world? Okay, so the second question is, when you say value transfer can be lossy and can take a less secure route, I don't understand why. So maybe I think I need to be more specific in what I mean by less secure route. So there is one route which is using all the available validator set of the Ethereum blockchain. And so if you are trying to basically pass messages from L1 to L2 using the L1 L2 bridge, you are effectively using the whole validator set of the Ethereum blockchain to pass that message from L1 to L2. And so that is the most secure route. A little bit unsecure route is by using an oracle, which does not have as much economic security as the whole Ethereum POS system, but maybe just is a multi-sig, or maybe it's some set of a reduced oracle where instead of relying on all the whole POS stake, you just rely on a subset using eigenlayer, things like eigenlayer, or use things like Chainlink to transfer messages across. So both of these have a reduced economic strength, which is why they're less secure than using all the validator set. And so what you're trying to optimize, what you're trading off over there is, instead of getting all that security of all that validator set, you leverage this reduced validator set and get better price or better speed. Yeah, so the latest question is standardizing chain abstraction at this stage a good idea? Does only standardizing make CA reality? Cause orchestration of all different kind of intents is a complicated task. So I think like we have the basic building blocks available now. So we have, like, people are talking about intents, defining different type of intents. You have stuff like eigenlayer, where you can use a reduced set of trusted set of validators. You have things coming up like ZK. You have all these different type of solver systems, solver networks. So, and people have also played around with different type of auction mechanisms. So I think the basic building blocks is all there. It's just that we need to still figure out how to. dApps just need one way to basically one single thing that they need to change, and they are compatible with everyone down the stack. Wallets just need to understand what is one single thing that they need to do to be compatible with everyone upstream and downstream, and everyone in their particular layer sort of is trying to wait for where the buck is moving. And that is what we are trying to do by standardizing all these different interactions. Obviously, like we are in the blockchain space, things move very quickly, and so we still need to be cognizant that something might come up 5 years in the future. But even because we have this problem right now, the best thing that we can do is improve the communication between all these different parties by standardizing stuff. Just DM me on Twitter.
For those that missed, the question was what's the best way to reach out to Ankit? So if anyone's interested, also Ankit, feel free to share your Twitter and chat in case others would like to follow up as well. It's going to make it really convenient. And other questions, everyone? It doesn't look like it. While we're still waiting, I'll give it a couple of minutes. Just I will use the opportunity to showcase what is next in the chain abstraction series. And while we wait for the very last questions, for those of you that are here, we've just listened to the Cake Framework workshop from Ankit, and which is going to be the last for this week. And next week we have a couple of workshops coming in from Avail. We have Prabal, who is the co-founder, talking on the Nexus and the true unification, which is going to be a talk on Monday. And then on Wednesday, we're going to have a talk from Brian from Polygon on what is Aglia and how is seamless cross-chain UX achieved. So a lot of great topics to listen to. I hope you'll be able to attend. I don't see any questions coming in, so maybe I get some closing words from your end.
No, thanks a lot for having me. Thanks a lot for everyone's time. I hope this was helpful. DM me if you have any questions. I have posted my contact in chat.
Thank you so much. Thank you, Ankit. Wishing you a great day. Wishing you all a great day. Thank you for being here, and see you all next week. Cheers. Bye-bye.